Hey everyone, welcome back to DataSpeaks. In this part 8 video in the binary classification machine learning project using bank marketing dataset, we are going to have a basic comparison of all the previous 3 models that we have trained and tested so far. That include the random forest model, logistic regression, and decision tree. And as we have already trained the model previously, these are the performance score. So here the training accuracy of the random forest was about 91.5, and then logistic regression was 84.46, and the decision tree had 76.06 percentage. Then the test accuracy here on all of those models respectively was 88%, 84%, and 75.56%. Test precision, same way as well, 0.49, 0.41, and 0.30. Or 49%, 41%, and 30%. Test recall, 78%, close to 79%, 81, close to 82%, and 86%. F1 score, same way, 61%, 55%, and 45%. And test ROC-AUC was 92.95, close to 93, 90, and then 87. So these are the performance score of each individual models that we have trained so far. And looks like so far random forest has almost outperformed all the models comparing to rest of the logistic regression and decision tree as expected. Now it is time to compare those models and build a hyperparameter tuning process for the best performing model, which is random forest. Let's quickly look at how we are performing hyperparameter tuning in this video, and then we will look if we can perform or make it random forest to perform any better with that tuned hyperparameters. We will use GridSearchCV or grid search cross validation to tune the random forest model. To do that, let's begin over here. So I will call the RF tuning pipeline, which stands for random forest tuning pipeline. We'll call the pipeline. And here earlier, we had set up the preprocessor that converts all those numerical values into the scaled numerical values and then fills out missing values, then performs also the one-hot encoding for the categorical columns, etc. Then we'll call the random forest classifier, and we'll call the class weight to be balanced, making sure that we handle those class imbalance problem, setting up reproducibility, and then also we are using all CPU cores for the faster training. So this is more of creating the pipeline for random forest model so that we can feed this pipeline to the next step. Then we want to set up some parameters grid for the hyperparameter tuning. So that includes n estimators or number of decision trees. We are choosing 2 distinct number of decision tree. That's going to be 100 and 200. And then we want to also choose the max depth to be 5 or 10. That decides the maximum depth of the each individual trees. And then min sample split, that also tells us the minimum number of samples required to split an internal node. We are choosing that to be 5 and 10 and see which one is performing better. Then min sample leaf, we are choosing that is minimum number of samples required to be at the leaf node, which we are choosing to be 2 and 5. We're passing these parameters grid to the random forest and see which one will give us the better accuracy. Then here we are calling stratified k-fold cross validation, and we are choosing 5 split, or we are choosing 5-fold cross validation. And here this is how we will be splitting the data into 5-fold, and we are training with the 4-fold each time and then testing or validating with 1-fold. So then it is time to set up the random forest grid search that will pass on GridSearchCV or grid search cross validation. Then here we are passing on the RF tuning pipeline, which we have set up right here at the top. And that will then take the parameter grid. So we will pass on this parameter grid for the random forest to tune and check which parameters are giving the best accuracy. Then scoring mechanism is going to be ROC-AUC score. Then we are passing the CV, the cross validation strategy here that we have defined just above this line. Then here we are passing n jobs to be -1, just passing through all CPU cores for the faster processing. And then we want to also show the progress as the tuning is happening. Then we want to fit our X-train and Y-train, the training data, into the random forest grid search or grid search cross validation for the random forest model. So doing that, we'll be able to find out the best hyperparameters that gives the best performance using this random forest model. Let's run this code and let's see what result we are getting using the grid search cross validation. This will take some time to complete the training. Here we got the training completed within 20 seconds, but based on the computer's capacity, it may take slightly more, it may take slightly less, but we have got the results from our grid search cross validation, and we have the results here that we want to evaluate. If we want to print all of those best parameter score and then what's going to be the best score with the best parameter, then we are here getting the best ROC-AUC score from cross validation is going to be 93, which is significant improvement than before. So which are the best parameter to achieve that 93.03% of the ROC-AUC score? Max depth we are setting none, and min sample leave 2, and then min sample split is going to be 5, and n estimators is 200. So we had passed on 100 and 200, so 200 happened to be really nice or best performing number of decision trees in the model. Now it is quickly time to evaluate the tuned model on the test set. So here with the random forest grid search, we're going to use the best estimator. So we will call that to be best random forest model. And then we will store the results into tuned random forest results. Then we'll call the function called evaluate classification model function, and we'll pass on best random forest model with the best estimators that we have looked at. Then we'll pass on the X-train, Y-train, X-test, Y-test, and we'll call that to be tuned random forest model. If I would run that, I'm getting a real nice, better promising result than before. So here I'm calling tuned random forest model, and then my training accuracy is 97, close to 98%, 97.5%. Test accuracy is 90%. That looks slight overfit problem here, but here the test precision is 58% and test recall is 62%. Test F1 score is 60%, and test ROC-AUC is 93.03%. And here, still our accuracy is significantly higher, 90%. And for the label being 0, for those customers who have not subscribed for the term deposit, we have got significantly high result, almost everywhere 95%. Then for the label 1 who have subscribed for the term deposit, we are roaming around 60%, which looks not a great result from the balance perspective, but much better than previous results. Here on the correct performances, where we have the true negative and true positive, they are good numbers here, and we are yet to do a good job on those false positive and false negatives, which we want to reduce significantly and make the model's performance better. So this might be the performance of this even tuned random forest might be because of imbalanced sample, imbalanced labels that might have caused this problem. But here, even though we have got a relatively good performing model, and here ROC curve here that shows us the area under the curve to be 93%, which is very promising. And here precision recall curve, of course, as we have seen, not a lot of promising results, but still we have the good results, we can say that. So in the next video, we are going to perform the comparison of all models, including tuned models, and figure out which one is the best performing model. Then we will perform the final prediction on the test data, and we will see what are the features that are most important for the best performance. Those features will be extracted using the feature importance technique. Then we'll save the model locally. I'll show you that all of those steps in the next video. Please do not forget to tune that. Until then, please enjoy learning, and thank you for watching until the last. If you have not already subscribed to DataSpeaks, please subscribe and hit that like button to this video. Thank you for watching. I'll see you in the next video.